Okay, so today we're going to talk about the sum of squared residuals and how to find that in your calculator. We are going to start with a set of values for your independent and dependent variable. So let's have that ready and inputted in our GDC. So I have L1 is going to be my variable for t over here, and L2 is going to be my variable for c of t. So as you know, the sum of squared residuals is a number that we use to compare between functions to decide which of those functions is a better fit for the model of our data. So let's take a look first at what our graph looks like for our scatter diagram. So I created a window here. I chose 0 to 15 for the independent variable and then 0 to 20 for the dependent variable, and I'm going to click graph. So looking at the set of data points that I have, it looks like a quadratic function is a good model to use for this set of data points. So what I'm going to do is a quadratic regression. So we're going to do a quadratic regression for this one. So I'm going to choose number 5, and then I'm going to input my list for L1 is going to be my X list and L2 is going to be my Y list. And I would like to store the regression equation in one of our functions that we have here. So I'll choose Y1 just so we could graph them later. Okay, so I'm going to calculate that regression equation. So this is my regression equation. If you go to Y, that regression equation is given, so that when I click graph again, the calculator will be plotting that regression equation for you along with the data points that you have. Okay, so there are two ways to find the sum of squared residuals. The first way is to find it manually. So let's find that manually first. So let's take a look at what is the actual residual from the data points that we have. So this is going to be I'm going to create a column first that gives me the function values at each of the numbers in the domain. So I'm going to use, this is actually the function value at L1. So of course you can copy all the parameters here and then input L1. But the faster way to do that will be to say, okay, I have L1, I go to L3 on that cell and I have the function at Y1. The calculator understands function notation, so I'm going to say on L3, give me the function values at L1. Okay, so this is like f of x. My function is L1, my function is Y1, my x values are in L1. Okay, so these are the function values dictated by my quadratic regression. So the residual is going to be the difference between the actual y values from your data set and the y values dictated by your quadratic regression. So it could be L2 minus L3 or L3 minus L2. It doesn't really matter. So let's do L3 minus L2. Okay, so these are your residuals. Okay, so these residuals, we want to square them. So I'm going to do L4 squared. Those are your residuals. Okay, so we just need the sum of the squared residuals. So these are your residuals, these are your squares. We just need the sum of this one. So we just go one variable statistics, and I'm going to get the sum of everything in L5. So that's stat calc. It's just one variable, and that's on L5. And then I want just the sum of that, so that's 2.7255. Okay, so that's the longer way of finding the sum of squared residuals. If I take a look at my I have my calculator, I have three extra columns created so that I will be able to find the sum of squared residuals. The faster way to find the sum of squared residuals is to actually use what we call the residual list that the calculator generates every time it does a regression. Okay, so if you notice, if I press second list, there is a list here with a name resid that stands for residual. So we just need to go to one of those free columns and say, give me that list of residuals from the regression. And you should be able to notice that actually that's similar to my L4 here, which means that that residual is actually L2 minus L3. Okay, so you can find the sum of squares of this one, and you can do stat calc one var stats, and then I use L6 because I was on L6, and then I'm going to get the sum of squares. So you should be squaring that. So that's the same answer from the previous 2.7255. So that number is not really meaningful in itself unless it is compared with another SSR or SSRes from another function that you have generated a regression equation for. Okay, so in this case, we're going to just take note that this residual is going to be refreshed. This list of residuals is going to be refreshed every time you execute a regression function. So when I execute another regression, let's say for a cubic or a quartic equation, this residual list is going to be changed. So you should execute your sum of square residuals immediately after you have done the regression for the function that you need the SSRes for.